The purpose of this tutorial is to demonstrate the method used to attach a strain gauge to a steel beam. Attaching a single gauge to a beam is commonly referred to as quarter bridge configuration. Throughout this tutorial, it is important to remember that the strength of the bond between the strain gauge and the beam is determined by how precisely this technique is followed. Cleanliness is of great importance, and any amount of dirt or grease on the gauge or the bar may cause the adhesive bonding process to weaken. The chemicals used in this process are non-toxic and generally not harmful, provided they are used in a safe manner. This tutorial promotes techniques that minimize risk to the person undertaking the tutorial, and instructions should be followed as closely as possible. This tutorial has been modified from the best practice method in order to simplify the process. At all times, a gauze wipe should be used to clean any surface once only and is then discarded. This prevents smearing of any debris across the clean surface. A strain gauge is a small flexible length of wire wound into a grid. The resistance of this grid of wire is normally 120 ohms, 350 ohms, or 1000 ohms. There are also two soldering pads on the strain gauge to enable attachment of wires. There are also guide marks which indicate the center of the gauge so that the user can precisely lay the strain gauge in position. When a strain gauge is perfectly attached to a beam of metal, the strain placed on that beam is directly transferred into the strain gauge and, as a result of this strain, the resistance of the gauge changes proportionately. Tiny changes in the resistance are used to measure the strain effect, and precise instrumentation is required throughout this measurement process. Cleaning procedure. Put safety glasses on. Gather together and prepare all the necessary equipment required for this tutorial. These items are insulation tape, a scribe, a spray can of CSM degreaser, M-Prep Conditioner A, M-Prep Neutralizer, plastic tweezers, lint-free gauze wipes, a single strain gauge, M-Bond 200 adhesive, M-Bond catalyst, 220 grit sandpaper, mylar tape on a dispenser, a clean smooth surface such as a pane of glass or acrylic, polyurethane coating, M-Coat A. Work out exactly where on the beam the strain gauge is to be placed. The location of the gauge should be the point on the beam which experiences maximum bending strain. The user should mark out this area very roughly with a scribe or some tape. Clean the smooth surface first with degreaser and a gauze wipe, and then with a new wipe and M-Prep Neutralizer. Place the strain gauge onto the clean, smooth surface and use the plastic tweezers to position the gauge in the correct orientation. Cut a length of approximately 10 cm of mylar tape from the dispenser, making sure not to touch the tape with fingers. Fingers will always have natural grease on them, and the tape will pick this up and may contaminate the gauge. The best way to avoid this is to create a tab at either end of the length of tape. Hold the tape along the length of the gauge and stick the gauge down to the smooth surface with about 10 mm of length between the bottom of the gauge and the bottom tab of the tape. Leave the gauge stuck in this position for now as attention turns toward cleaning the bar. For any form of mild steel, it may be necessary to use a strong abrasive to remove the top oxide layer of the steel. This may be 120 grit sandpaper or linisher. Care should be taken to produce a completely smooth and even surface on the area to be gauged. With the gauging area marked out, use some CSM degreaser and gauze wipes to clean the gauging area. This step should be repeated until no more grease comes off the surface of the beam. Take a piece of 220 grit sandpaper in one hand and the M-Prep Conditioner A in the other hand. Add a few drops of the conditioner to the bar and use the sandpaper to rub the gauging area, using about a dozen strokes along the length of the bar. Clean off the residue using 2 gauze wipes, disposing of the wipe after each pass through the gauging area. Clean a metal ruler with Neutralizer 5A and a gauze wipe. Mark out the location of the gauge on the bar with a scribe or 4H pencil. A 4H pencil is preferred. If using a scribe, be careful not to enter the gauging area as this will introduce burrs and scrapes on the surface. Scrub the gauging area with the gauze wipe and Conditioner A. Now flood the gauging area with M-Prep Neutralizer 5A and use a gauze wipe to remove the excess liquid from the area. Care should be taken to ensure that no liquid is left on the gauging area, as this may contaminate the glue bond. The gauging area should be completely clean and dry and is now ready for the strain gauge to be attached. Strain gauge adhesion procedure. Return to the strain gauge, which should still be stuck down onto the smooth surface. Peel off the tape by pulling at a very shallow angle on the top tab of the mylar tape. This ensures minimum strain is put on the strain gauge as it is removed from the surface. Pull the tape lightly until the gauge is completely removed from the smooth surface. Holding the tape by the tabs, line up the strain gauge with the marks left on the beam. When confident that the gauge is correctly lined up, stick the gauge down on the bar. Using the same technique as before, peel the tape back until the gauge has been lifted off the bar and 2 to 3 mm of tape below the gauge is available. Fix the top part of the tape to the bar so the gauge is fully exposed. Open the blue catalyst and touch the brush to the lip of the jar approximately 10 times. This reduces the amount of catalyst on the brush so that the right amount will be applied to the gauge. Coat the back of the gauge with catalyst using one firm brush stroke. Pull the brush off to the side of the tape to avoid leaving any excess catalyst on the gauge. The next steps must be carried out quickly and accurately to avoid the glue setting before the strain gauge is properly placed. Detach the tape from the beam and hold in one hand. Using the other hand, place a small blob of glue at the interface between the tape and the beam. Put the glue down on the bench and use the tape tabs to position the strain gauge into the correct place. Use the thumb to smooth the strain gauge onto the bar, making sure to apply pressure so that no bubbles form underneath the gauge. Once the strain gauge is flat on the surface of the beam, place the thumb or finger onto the back of the tape directly over the strain gauge. The heat from the thumb will assist in curing the glue and will help the strain gauge stick to the bar. The pressure from the thumb will also ensure that the amount of glue beneath the strain gauge is not too thick. Too much glue will prevent transfer of strain to the gauge. Too little glue and the gauge will become unstuck. Hold the thumb in position for over 3 minutes. Once 3 minutes have elapsed, remove the thumb by twisting it 90 degrees from the bar and then lifting. Allow the gauge to sit for at least a further 2 minutes before removing the tape. To remove the tape, peel back the tape at an angle perpendicular to the direction of the strain gauge. Soldering the tabs. Allow enough time for the strain gauge glue to fully set. This could be 2 to 3 hours or 24 hours for a full cure. Put safety glasses on. Tools required are soldering iron, solder, fume extractor, two 30cm lengths of 7/0.2mm wire, side cutters, insulating tape. Place some insulating tape across the strain gauge so that only the solder pads of the gauge are exposed. Turn on the soldering iron. Make sure that the sponge of the soldering iron is wet. Use the side cutters to strip back the insulation of the wire by approximately 10mm. Twist the 7 strands of wire together as tight as possible. The tighter the twist in the wire, the easier the solder will transfer to the wire. Turn on the fume extractor. Making sure that the soldering iron is up to temperature, clean the tip of the soldering iron so that the tip appears as a shiny metallic colour. Add some solder to the tip of the iron so a small bubble of solder is left on the tip. This is called tinning, the soldering iron tip. Bring the bubble of solder onto the twisted end of the wire and add more solder to the bubble at the point where the tip is touching the wire. Solder should flow onto the wire and be sucked up into the core by capillary action. When the wire tip appears fully coated with solder, remove the tip of the iron and clean before returning the iron to the holder. Repeat the previous step for the second pre-prepared wire. Use the side cutters to reduce the length of the bare wire to about 3 to 4mm. Place the wire on the bench. Check that the tip of the soldering iron is clean. Tin the tip of the soldering iron. Quickly bring the bubble of solder onto the pad of the strain gauge and add more solder to bubble so that solder flows onto the pad of the strain gauge. This should not take more than 5 seconds. Remove both the iron and the solder at exactly the same moment so that a smooth bubble of solder is left on the pad. Repeat the previous step for the second pad. Clean the iron tip and return the soldering iron to the holder. Allow some time for the strain gauge to cool down. At this point, it is a good idea to check the strain gauge with a multimeter. Check that the resistance is still approximately the correct value between the two pads. Also check the resistance between the beam itself and the two pads. On rare occasions, it is possible for solder to melt through the pad and attach to the beam, causing a short circuit. Tin the tip of the soldering iron. Bring a pre-soldered wire close to one of the solder pads of the strain gauge and use the tinned soldering iron to melt the solder. Push the wire into the melted solder pad so that the bubble of solder completely encapsulates the tip of the wire. Remove the soldering iron and clean the tip. Repeat the previous steps to attach the second wire to the second soldering pad. Clean the soldering iron and return it to the holder. Remove the masking tape from the strain gauge carefully. Some form of strain relief on the cables of the strain gauges is highly recommended. This will prevent any pulls on the wire from applying force to the strain gauge itself. The simplest form of strain relief is a piece of insulation tape across the two wires, fixing them to the beam. Coat the strain gauge and wires with polyurethane coating to prevent moisture ingression and to strengthen the bond of the gauge. Allow 20 minutes for the coating to dry. Check the strain gauge resistance value with a multimeter. Also check the resistance between the pads and the steel beam to make sure there is no electrical connection. The strain gauge is now attached to the beam and can be connected into signal conditioning to measure the strain on the beam.